Evolution of computers and processors has been a fascinating journey marked by advancements in technology. My name is Kalungi Edward, a student of computer science, year 1, and this is my solution to the assignment. The question says, briefly explain the evolution of computers and processors. Evolution of computers is in generations. The term generation in computers refers to every advancements in technology. Well, in the 1940s marks the first generation, and computers used vacuum tubes for processing. These computers were so huge, they occupied rooms, and since they were using vacuum tubes generated a lot of heat. Examples of computers that were in the first generation, we have the ENIAC, and then we have the IAS. The IAS computer was developed in the Princeton University, and they started working on it in 1947 and they finished working on it in 1956. It had a storage of 5 kilobytes and it was used for solving mathematical problems. In 1956 to 1963, that's when you have the second generation of computers, and these computers used transistors for processing. They were much smaller than the first generation computers. They could take up one small room, and since they were using transistors, the heat reduced and they were much cheaper and easier to use. In the third generation, computers used integrated circuits. They were able to use silicon chips, and they fitted many transistors on those chips. So that's when we see advancements in technology. IBM developed its first architecture where everything could fit on a desktop. That's when we saw the personal computers were made. That's when many computer advancements and many companies took on the architecture and started to develop the computers. Still during the third generation, as a result of these advancements, again, many machines were cheaper and smaller, and a new mass market for users emerged. Examples of the computers, we have the IBM 30, we have the IBM 370, and the TDC 316. The third generation was between 1964 and 1971. In 1971, that's when we have the fourth generation of computers. Now, during the fourth generation, microprocessors were used for processing. They were very much smaller, and they could fit thousands and thousands of transistors on a silicon chip. And that's when we saw the development of the Intel 4004. Now, considering from the fourth generation, it is debated whether we go to the fifth, because we have the development of the very large scale processors, and here it only depends on how many processors and cores that they are able to fit on a chip. If we were to take a case study of the Intel, I am going to show a spreadsheet that you can follow. But then we saw the Intel shift from the Intel 4004 to the Intel 8008 in 1972, the Intel 8086 in 1978, which was much faster at 5 megahertz and 16-bit core, and it had over 29,000 transistors and about 3 microns. And from the Intel 8088 we moved to the Intel 286 in 1982, much faster, 16 megahertz. And then from the Intel 286 we went to the Intel 386 in 1985, which was way faster than the previous one because it moved from 6 to 16. And then we have the Intel 486, that is 1993, and this was a 25 megahertz 32-bit core processor, and over 1.2 million transistors were able to fit on one small chip. And in the 1995 we saw the Pentium core that was introduced by Intel, and it could still fit 32. It still used a 32-bit core, and over 5.5 million bits that could fit on one small chip. And the microns were about 0.8 microns. Well, we did have the Pentium Pro, Pentium 2, the Celeron, Pentium 3, Pentium 4, and that is between 1993 and 2000. And processor speed also moved from 22 to 66 up to the Pentium 4, which was at 1.5 megahertz. And then the Intel shifted from the Pentium series, and then we have the development of the Xeon that's in 2001. Speed was at 1.7 megahertz, and then from that we did have another Pentium come through, that was a Pentium M in 2003. Its speed was 1.7 megahertz, 32-bit core, and over 151 million transistors could fit on one small chip. Intel then developed the Core Solos Duo in 2006. The speed went up to 2.33 gigahertz, and it could now have 2 core processors on one small chip. And then we moved from the Core Solos to the Core 2 in 2006, still at 2.66 gigahertz, and then it had a 64-bit core processor, and it could have 4 cores on that small chip, and over 291 million transistors on a small chip. And then in the 2008 we have the Intel Atom. Speed went down a bit to 1.8 gigahertz. It could 32-bit core processor, and it could fit 8 cores on a small chip. And then in the 2008 still we saw the Core i3 and i7 and i5. These were also 64 bits. They could have over 4 core processors, and on a small chip. Transistors went into 700 millions. Well, in the 2017 we saw the development of the i9, Core i9, the Intel i9, which went up to 3.3 gigahertz, 64-bit, and 10 to 18 cores could fit on one small chip. Then yes, that is the Intel processor. Now, fifth generation, if I'm to talk, that is the 4th generation that I was talking about. And if we are to talk about the 5th generation, we saw the development of different AIs. we saw cloud computing coming in. We have seen the use of interconnections, the Internet of Things, iOS, and IoT, sorry, the Internet of Things. Now, if I'm to talk a bit about artificial intelligence, we have seen it advance in the last 5 years, so to speak, and we have seen the development of how it has been able to help us make robots, how it is helping us write different codes, how it is also helping us do a lot of things. And some would call that now we are in the 5th generation of computers, where everything is aided and can be helped and coded and transformed into an AI that makes everything easier and better to use. And still in the 5th generation, cloud computing, where now it's not a must to have everything that you need in a room on a computer, whether you need memory, whether you need processing power, where now you can access all those things over the cloud, so to speak. But the cloud is basically someone having all these facilities in different locations, and you only need to pay and access them and access those services. If I'm to give an example, like I need to back up something, I need to store something, but then I don't have enough storage on my phone, I can use an application called Dropbox, where I can access someone's servers elsewhere, and then I can upload all my files and store that from that side. And also, if I need to process, I need workbooks, I need spreadsheets, I need Word, I need PowerPoint, and I don't have the required items to use, I can use the Google Docs or Google Drive to back up all my work and access them from that side and work everything from that side, and then I can do everything from there. And still in the 5th generation, we see the Internet of Things, which is basically able to connect smart devices together. You can control how your microwave is operating using your phone. You can control what you're going to see on your TV using your phone, and even more advanced tech, where you can turn on and off lights, where you can go through your phone and speak to the door and tell it to close itself if it has embedded systems that are able to carry out that particular instruction. And more about the Internet of Things and the interconnection therein, and how we connect to all these things. That's where most of the things that we are dealing with today are coming from. And if to describe a bit more of that, we can see the sensors that are coming in. If too much light, what's the weather, all those things that are helping us to do all that. Yes, and that is to talk about the generation of computers. Next, I'll be talking about the evolution, the second question, which was talking about the ARM, and the